Hello guys, today we're going to be talking about three things. We're going to talk about binary arithmetic, hexadecimal arithmetic, and octal arithmetic. What I mean by arithmetic: first we're going to cover binary addition, and okay, that's a little bit hard. Let's see. This is clear. Binary addition. For example, what's binary? Binary is base 2. From base 2, I know my range of numbers is 0 and 1 only. That's binary. The language of the machine. Adding two binary numbers. For example, if I want to add, let's say 29 plus 15, that should give me what? 9, 14, 44. Let's see how to do this in binary. What's 29 in binary? 29 in binary is, and we took that in the previous videos, let's put 1, 2, 4, 8, so we can represent what? Binary. 32, I don't need the 32. 16, 24, 28, 29. This is 29. What's 14 or 15? 15 is so now I need to add both of those, which is, this is representing 29 and this representing 15. This is in binary. In binary, remember, I have those cases. 0 plus 0 equals 0. 1 plus 0 or 0 plus 1 is what? 1. 1 plus 1. Here we have two cases, let's say. Some people use 2 and I use 10. Why do I use 10? We said the range of numbers is 0 to 1. Binary, 0 to 1. In decimal, what do we have? Which is base 10. My range of numbers is 0 to 9. Those are the decimal numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. 10 is two decimal numbers using 1 and 0. But what do I have after the 9 in decimal? It's the 10. That's why some people consider it here as 2. Why do I consider it as 10? I'll show you in a minute when we add them. 1 plus 1 plus 1. And I'll show you when we face that scenario. I consider it as 11. 1 and a carry of 1. Here 0. Let's see. 1 plus 1, 10. 1, 0 and 1. 1 plus 0, 1 plus 1 is 10 again, and I have a carry of 1. Here I'll have the case of having 3 ones. 1 plus 1 plus 1 is what? Think of it as 11. 1 and a carry of 1. And here what do I have? 1 plus 1 plus 1. That's 11 again. And here I have carry 1, 10, 1. So what does this number represent? This is binary addition. So this is going to be what? 1, 2, 4, 8, 16, 32. And remember, those, what do they represent? The power of 2s, to the power 0, to the power 1. What will this equal? 32 plus 8 plus 4, which is 44, which is our answer. This is the binary addition. Now let's go to binary subtraction. And let's subtract the same numbers. So we don't have to go throughout convert into binary again. Binary subtraction. But I wanted a case, okay, we have a case where we have to borrow, and that's what I wanted. Is binary subtraction. Same numbers. 29 minus 15 should give me 14. And binary subtraction, we have two ways. Let's do the subtraction first, and then we convert it to the other way, which is addition. 1 minus 1 is what? 0. 1 minus 1 is 0. 0 minus 1, can I do that? No, I have to borrow. I borrow from here. 0, what do I have? Think of 10. We borrowed 10. We borrowed from the 10th place, if you think. The 110th. Now look at this. 9, 5, 4. What does the 5 represent? A 5. What does this represent? 9. So when I borrow to the 5, if I said 8, what did I borrow? I borrowed 10, but you put it as 1. And here, if I borrowed for this represents 400. If I borrow, I actually borrow 100. That's why I put it as 10. 10 minus 1. Where did we have 10 before? When I had 1 plus 1 equals 10. So now I say 10 minus 1, it's going to give me what? 1. 0 minus 1, can I do that? No, I have to borrow. This is 0, this is 10. 10 minus 1 is 1. Here I have to borrow again. This is 0, I have 10. 10 minus 1, 1, 0, 0. This should give me what? 14. What's this? 1, 2, 4, 8. So it's going to be 12, 14. This is 14 in binary. There's another way to do it. Let's look at the other way. Remember we took in the previous video, we took what? The 2's complement. I said 29 minus 15 is equal to 29 plus negative 15. And I'll find the 2's complement for the negative 15. How do I find the 2's complement for the negative 15? I'll find the 1's complement, which is what? Flipping 1's to 0's. And let's make it 8-bit in our case. It's always good to make it 8-bit. Let's do this. This is 1's complement, so you don't confuse it with. And 8 bits, I'm going to have 0, 0, 1, 1. I always like to deal with a byte if you're doing 2's complement. So this is what? Negative 15 in 1's complement. I add 1 to it to get what? The 2's complement, which is this. And then I add it to 29. So I have 1, 0, 0, 0, 1, 1, 1, 1. Let's see now if it's going to give me the correct answer. 0, 0, and I make it 8 bits. I have to make it 8 bits as this. This is what? 29. And now I add to it the negative 15. What's negative 15? 1, 0, 0, 0, 1. Let's see. 1 and 1, 10, adding, I'm adding. And this is 1, 1, 1. Now 1 plus 1 is 10. 1 plus 1 is 10. 1 plus 1 is 10. And I have a carry of 1. Remember, I can't put it here because I only need 8 bits, which are a byte. This will go to the flag register, and we'll see what happens to it later on. What should this be? Is this 14? 1, 2, 4, 8. This is 14 in binary. So my answer is right. 0, 1, 1, 1. 0 is what? 14. This is where I convert the subtraction to addition, and I take the 2's complement of the negative 15. I take it by finding the 1's complement. 1's complement is flipping every 0 to 1 and every 1 to 0. To find the 2's complement, I add 1 to the 1's complement. So this is the 2's complement representing the negative 15. I add it to what? 29, and it gave me 14. We got the right answer. So now we're done with base 2, binary, which is the machine language. We took 2 other bases. Let's say base 2 was, let's do the octal first. 2 octal, and let's do the addition. Octal, what did we say? It's base 8. From base 8, what can I get? No, I know my range of numbers is from 0 to 7. That's the only possible numbers I can get. And remember, when we were grouping, converting to binary, I do what? Group into 3's. Why? Because 8 equals 2 to the power 3. From 3, I know I have to group into 3's. This is 2 to the power 3. So now let's take this number. Binary addition, octal addition. Let's say I have 7. 1 minute. Let's do 6, 1. If I had an 8, is that right? No. Why? Because 8 is not an octal number. My range of numbers is from 0 to 7. Now let's put this 2 and 1. I'm trying to add those 2 octal numbers, meaning base 8. Base 8. And let's make this 2. I did it 2 on purpose. 6 plus 2 is what? Is 8. What's 8? If I had 9 plus 1 in decimal, decimal is base 10. This is base 8. So it gave me 9 plus 1 is 10, and 1 overflow. Let's say I have this 29 plus 11. 9 plus 1 is 10, and this is 4. I had on a 10 a carry of 1. On an 8, this is a 0. Think of it as a 10. Now I have 1, 5, and 7. This is 12, 13. 13, what do I have? I'm going to have a carry of 1, which takes the 8. How much am I left with? 5 and 1. 1 representing what? the 8s we got. Why? Because it's base 8. So now I have 1 and 2, 3, 4. This is octal, base 8. Let's do also the subtraction. I have space here for subtraction. So how can I do the subtraction? Let's subtract what? Should we do it the same? No, I want to do some borrows. So let's have 300 minus 271. And this is, let's do them separately. This is octal, base 8. Can I subtract 0 from 7? No. What do I need to do? Borrow. When I borrow, how much am I borrowing? I'm left with 2. I borrowed 8, which is 10 in decimal. I borrow again, so this is 7. Now I have 8 here. 8 minus 7, what do I have? 1. 7 minus 2 is 5. 2 minus 1 is 1. This is in octal, base 8. This is the addition and this is subtraction. Be careful here. When I add and get an 8, that's going to be considered as 10. 0 and 1. And what's the 1 actually? It's the 8 that I carried. When I borrow, remember in decimal, if you had to borrow in decimal, let's say I have 21 minus 19. Can I subtract 1 minus 9? No, I need to borrow. What did I borrow? I borrowed a 1, but it was a 10. So now I have 11. 11 minus 9 is 2. And this is 0. But this is decimal point 10. This is octal base 8. So what I borrow is 8 actually. So I'll have 8 minus 7 is 1. I borrowed 1 from this before. So 7 minus 2 is 5. Now I have what? Let's do the hexadecimal addition and subtraction. We have the hexadecimal addition and subtraction. Hexadecimal is base what? Base 16, meaning the range of my numbers is from 0 to 15. And because what? I have from 0 to 9 normal numbers, single digits. 10 is what? 10 is considered as 2 digits. So instead of that, we put an A. 11 is also 2 digits. We consider 11 as B, 12 as C, 13 as D, 14 as E, 15 as F. And remember, this is 2 to the power 4, meaning I group into 4s if I'm converting to binary. For example, let's say I have what? Let's do the addition first. I'm adding 2 hexadecimal numbers. So A and 6. E and F, 2 and 5, put a BNG because I just want to make a mix of numbers. Base 16. Remember, decimal is base 10. This is base 16. So decimal, when I say 9, or let's say 6 plus 4, it's 10. And decimal, my base 10, my range of numbers is 0 to 9. So the 10 is the 0. Here the 16 is the 0. And let's see how we do it. A is what? A is 10 plus 6 is 16. Do I have a 16? No. So it's going to be what? A 0 and 1. This is the 16. Now let's see what I've got. E is what? 14 plus what? F is 15. So that's 29 plus 1. That's 30. I don't have a 30. So what do? I do 30 minus, if I have addition, I subtract. Minus 16. This minus 16 is going to be what? The carry. Minus 16, I'm left with what? 14, which is E, and here's the 16, which is a carry or overflow. This is what? 1, 2, and 5 is 8. 9 and 8 is what? 17. So I'm going to have a carry. Minus 16 is 1. 1 and 1. And look at this. This is really important. I have 1 and B. B is what? 11. So this is 12 plus D, which is 13. I have 25. Do I have 25 in hexadecimal? No. Don't put 25. This is wrong. Why? This is in decimal we do that. Here, I subtract 16. It's going to be 9, an overflow or carry of 1. So now I have 19. 19 is different than 25. Be careful, guys, for this point. Now let's do the subtraction. The subtraction, I'm going to need to do some borrows. So let's put, I haven't used the C. Let's put the F here. And let's do a borrow with a 0. E. D. A and 2, and this is 9. And here I'm going to do subtraction, hexadecimal. All those are base 16, base 16, base 16, base 16. C minus F. What's C? C is 12, F is 15. Can I subtract 12 from 15? No, so we're going to have to borrow 0. What did we borrow? We borrowed 1. But what's the value of 1 in base 16? It's 16. So I have C, which is 12, plus the 1 I borrowed, which is 16. So now I have a total of 28. 28 minus F, which is what? 15. So I'm left with 13. 13 is what? D. Now what do? 0 minus 9. Can I do that? No. We have to borrow. What do we borrow? This is E. Now it goes to D. E is 14. D is 13. And I borrow 1. What did I borrow actually? 16. 16 minus 9 is 7. D minus A. D is 13, A is 10. So 13 minus 10 is 3. D is 13. Minus 2 is 11, which is B. Be careful, don't put 11. Put characters. 11 is 2 digits. This is the hexadecimal addition. Those mostly, so we covered binary addition, subtraction, octal addition and subtraction, and hexadecimal addition and subtraction. This will be good.